All right, let's jump right in. Today, we're going to talk about something that is a huge deal for, well, pretty much everyone these days, multi-cloud. More specifically, how in the world do you get all those different cloud environments to actually connect and work together? Let's figure it out. I mean, this is the reality, right? You've picked the absolute best services from different providers, which is smart. But now they're all living on their own separate digital islands. So getting them to communicate and to do it securely and efficiently, that's the whole ballgame. And it all starts with the network. Now look, multi-cloud is a massive topic. You've got to worry about security, consistent governance, who has access to what, so much stuff. And all of that is super important. But for today, we're going to laser focus on just one piece of that puzzle, the foundational network connectivity that makes everything else even possible. To really get how to connect multiple clouds, we've got to take one step back. We first have to get a solid grasp on how the network inside a single cloud provider actually works. This is our foundation. So the core concept here is the virtual network, or VNet. The easiest way to think about it is like your own private, isolated slice of that cloud provider's massive network. You get to define its IP address space, and it basically creates a secure container for all your virtual machines, your databases, and your apps. And these VNets, they have some pretty strict rules. It's got to live inside one subscription and one single geographic region. It can't stretch across them. Inside that VNet, you chop it up into smaller pieces called subnets to keep things organized. You can even bring other services, like a big database, directly into your network using something called a private endpoint, which gives it a private IP address just like everything else. Okay, so we have our little network world in the cloud, but most organizations still have their own data centers, what we call on-premises. The next logical step is building that hybrid bridge to connect those two worlds. And you really have two main ways to build that bridge. You can go the public route using the internet with a site-to-site VPN. It works, it creates a secure encrypted tunnel, but your performance can be all over the place because, it's the public internet. Or you can go the private route with a service like Azure's Express route. This is a dedicated, private line that never touches the public internet. That means it's more secure and you get way more predictable performance. And when we say private, we're not kidding around. The scale of these networks is just mind-blowing. The major cloud providers run their own massive global backbones. Microsoft's, for example, is over 165,000 miles of fiber optic cable. This isn't just a connection, it's a private superhighway that makes all these high-speed, reliable connections possible. So how does your data actually make the trip? Well, it starts in your data center, travels through a carrier's network to a physical building called a point of presence, or a POP. Think of it as a meeting point. From there, it gets handed off directly to the cloud provider's private global network, which zips it straight into your VNet, completely bypassing the messy public internet. Okay, so we've connected our data center to the cloud. We get it. Now for the main event. How do we take everything we just learned and use it to connect one cloud provider, like Azure, directly to another, like AWS? And this is the secret. And the secret is, there is no secret. Seriously, there's no magical hidden technology for connecting Azure to AWS. The exact same tools we just talked about for connecting your own data center, the VPN and those private connections, are the very same tools you use to connect different clouds to each other. That's it. The only real key is knowing the brand names, because everyone calls it something different. Every major cloud has their own version of this private connection service. So in Azure, it's called Express Route. Over in AWS, it's Direct Connect. For Google, it's Cloud Interconnect. And for Oracle, it's Fast Connect. But they're all doing the same fundamental thing, giving you a private on-ramp to their network. So look at this direct comparison. To connect to another cloud, you can use a VPN over the internet, same as with your data center. Or you can use the private connections. The only difference is, instead of connecting your data center to a POP, you're connecting, say, Azure's network and AWS's network together at that exact same shared point of presence. It's that simple. Now, the number one rule for performance in multi-cloud networking is so simple. Latency is all about physics. You cannot beat the speed of light. To get the best performance, you have to choose cloud regions that are physically close, like an Azure region in London and an AWS region in London, and then connect them at a shared POP right there in London. Your data has to make that physical round trip, so keeping it short is everything. So the concept is pretty clear. Now let's talk about the practical choices you've got to make when you actually go to set all this stuff up. You've basically got two flavors here. Option one is Go Direct. This is for the serious networking experts who want to manage every little detail themselves, the physical ports, the complex routing, to get absolute max control and speed. The second, and much more common option, is to use a cloud exchange provider. Companies like Equinix or Megaport handle all that gnarly complexity for you. It's a way simpler experience, and it's perfect for most people. Okay, now this part is hugely important. Whatever connection method you choose, you absolutely positively cannot create a single point of failure. If your entire multi-cloud strategy relies on one single cable in one single building, you are just asking for a very, very bad day. So how do you build in that resilience? Here's your checklist. First, use at least 2 private circuits. Second, make sure they connect to different points of presence, ideally in completely separate buildings. That way, if one building loses power, your other link is still up and running. And for an extra layer of safety, you can always have a site-to-site VPN configured as a backup, just waiting to take over if your private links ever fail. And just a couple of final but absolutely crucial reminders. First, DNS. Your services find each other using names, not IP addresses, so you have to make sure you have a consistent DNS system that works across all your clouds. It's non-negotiable. Second, look for performance boosts. Things like Azure's ExpressRoute FastPath let your traffic bypass certain gateways, shaving off precious milliseconds of latency, which can make a huge difference. And so, that brings us full circle. We've solved the networking problem, the clouds are physically connected. But really, that's just step one. The much bigger question this opens up is, now what? How do you manage it all? How do you apply one security policy, one set of rules, and one identity system across these totally separate environments? And that is the next great challenge in the multi-cloud journey.